Okay, so today we're going to go over the stoichiometry problems that you guys had for homework. The first question says, if you add 250 grams of sodium chloride, how many moles of chlorine can be produced? So here we have our balanced chemical equation. I went ahead and I underlined and I wrote what everything that was given to me in the problem. So 250 grams of sodium chloride, I wrote it under sodium chloride. And they were asking me for moles of chlorine, so under chlorine I wrote a question mark. So in this question, they're giving us the information in grams. So, and they're asking us to find moles. So we're going from grams to moles. Remember that in this type of question, since we start in grams, we first have to use molar mass, then the molar ratio. Okay, so the first thing I'm going to do is I'm going to write what was given to me in the problem. 250 grams of sodium chloride. Write the number, the unit, and the compound that was given to you in the problem. Next, remember that you're always going to want to use the mole ratio in order to jump from one compound to another. But in order for you to use the mole ratio, you need to be in moles. And right now we're not. Right now we're in grams. So I need to go from grams to moles. And I'm going to do that by using the molar mass. So I need to find the molar mass of NaCl, sodium chloride. I'm going to go ahead and go to my periodic table, look for sodium, which is in group 1. The mass of sodium is 22.99 grams per mole. And the mass of chlorine, according to the periodic table, is 35.45 grams per mole. I add both of these numbers and it gives me 58.44 grams per mole. So the molar mass of this whole compound is 58.44 grams per mole. I'm going to get this number and bring it up here. Put it in the bottom. 58.44 grams of sodium chloride for every 1 mole of sodium chloride. Remember, the molar mass tells you how many grams 1 mole of that compound weighs. The reason I wrote the grams in the bottom is so that grams of sodium chloride and grams of sodium chloride cancel each other out. Now that I am in moles of NaCl, now I could go back to my balanced chemical equation and look at the mole ratio. Remember that this ratio comes from the coefficient in your equation. If there's no number, that means that there's a 1, not a 0. So I have 1 mole of NaCl here in the top. So in the bottom, I want moles of NaCl. And I'm going to get how many moles from my coefficient? 2. So for every 2 moles of sodium chloride, I produce 1 mole of chlorine. This is a mole ratio. And remember, the reason that I put moles of sodium chloride in the bottom is that the moles of sodium chloride cancel each other out. Now, I'm going to go back to my question to see if I am done. The question is asking me for moles of chlorine. Right now, the only unit that's not crossed out is moles of chlorine, so I am done. Now, all I have to do is get my calculator, do 250 divided by 58.44 divided by 2, and I get 2.14 moles of chlorine. And that is my final answer. Problem 2 says, what mass in grams of SO2 is needed to react with 37.50 moles of oxygen gas? Okay, so they're giving us 37.50 moles of oxygen gas. So I'm going to go to my balanced chemical equation. 37.50 moles. And they're asking us to find what mass in grams of SO2. So SO2, they're asking us for question mark, grams. Okay, so this question is giving us the information in moles. So we're going to go from moles to grams. Okay, the first thing I'm going to do is I'm going to write what was given to me. 37.50 moles of oxygen gas. Okay, remember that I always need to use the mole ratio in order to jump from one compound to the next. But in order to use a mole ratio, I need to be in moles, which I am already. So my next step is going to be to use a mole ratio. Okay, because I am already in moles, so I could use the ratio based on the balanced chemical equation, the coefficient, to go from one compound to the other. So according to my balanced chemical equation, I have, if there's no number in front of a compound, that means that I have a 1. So I have 1 mole of oxygen. I put it in the bottom, remember, so the moles of oxygen and moles of oxygen cancel each other out. And then in the top, I'm going to put 2 moles of SO2. Like this, again, the moles of oxygen cancel each other out. Now, am I done? Let me see. The only unit that's not crossed out is moles of SO2. The question, it is asking about SO2, but it's asking for the grams, not the moles. So I need to do one more step in where I go from moles of this compound to grams of the same compound. So I need to go from moles to grams. And the way that I know how to do that is by using the molar mass. So I have to use a molar mass, find the molar mass of SO2, sulfur dioxide. Okay, so again, I'm going to go to the periodic table. Sulfur has a mass of 32.07. 32.07. I have 1, so times 1, 32.07 grams per mole. Oxygen has a mass of 16.00. There's 2 oxygens. Oops, you can't see this. There's 2 oxygens. So times 2, that is 32.00 grams per mole. I add both of them to find the total mass, and it's 64.06 grams per mole. Okay, so now I'm going to go up here and put this value up here. So 64.06 grams. I'm going to put it in the top. 0.06 grams of sulfur dioxide for every 1 mole of sulfur dioxide. The reason that I put it like this is, again, remember, so the moles of SO2 cancel out, and the only unit that's left uncrossed is grams of SO2, which that's what the question is asking me for. I get 37.5 times 2 times 64.06, and it gives me 4,805 grams of SO2. Okay, I could have also written it as 4.805 times 10 to the 123 grams of SO2. Okay, but this is fine. Now question number 3. It says, the decomposition of potassium chlorate, KCl3, into KCl and O2 is used as a source of oxygen in the lab. How many moles of potassium chlorate are needed to produce 50 moles of oxygen gas? So this question is a little bit different because the equation is not given to you, but we know how to figure out because it's giving us all the components here. Okay, so it says the decomposition of potassium chlorate. We know that this decomposition is we start off with one thing that's going to break up into 2 or more things. Okay, so we're going to start with KCl3, and that's going to decompose or break into potassium chloride and oxygen gas. Okay, now the next thing that we have to do is we need to balance this chemical equation because right now it is not balanced. I have 3 oxygens here and 2 on this side. So remember to balance under the arrow, I'm going to write all the elements, KClO. I'm going to count how many I have on each side. Okay, I have 1, 1, 3, 1, 1, 2. Okay, so the only thing that needs to be fixed are the oxygens. And I'm going to fix the oxygens by putting a 3 here. When I multiply 3 times 2, I get 6. So now here in front of KCl, I'm going to put a 2, so that when I multiply by 3, it also gives me 6. So my oxygens are now balanced. Remember, this 2 also affected K and Cl. So now I have 2 of each. So I will need to put a 2 here in front of potassium chloride. That also gives me 2. Everything is balanced. I am done. Okay, so now that I've balanced my equation, now I could go back to the second part of the problem that gives me the information. It's asking me for how many moles of potassium chlorate. So how many moles of potassium chloride are produced in 15 moles of gas? 50 moles of oxygen gas. Okay, so this question is giving me the information in moles, and they want me to find out the moles of another compound. So it's from moles to moles. So this is the simplest type of question that we can ask. Remember, that's only one step. Okay, but step 1 is to always start with what was given to us. 15 moles of oxygen. Okay, I always need to use the mole ratio in order to jump from one compound to the next. And in this case, I am already in moles. So my next step is to use the mole ratio, which the mole ratio is 3 moles of oxygen for every 2 moles of potassium chlorate. So 3 moles of oxygen for every 2 moles of potassium chlorate. The reason that I wrote moles of oxygen at the bottom, so they cancel each other out. Right now, the only unit left uncrossed is moles of KCl3. They're asking me for moles of KCl3. So I am done. Okay, so now what I'm going to do is I'm going to get my calculator, multiply 15 times 2 divided by 3, and it gives me 10 moles of KClO3. And that is my final answer. Problem 4 says 1 mass in grams of SiC is formed from the complete reaction of 2 moles of carbon. So they're giving me 2 moles of carbon. So under my balanced chemical equation, under carbon I write 2 moles. And they're asking me for the grams of SiC. So under that I write question mark gram. So this question is giving me the information in moles. And they're asking me for grams. So they want me to go from moles to grams, from moles of one compound to grams of another compound. Okay, so the first thing I do is I'm going to write what was given to me. 2 moles of carbon. Remember that I always need to use the mole ratio in order to jump from one compound to the next, but I need to be in moles. And in this case, I'm already in moles. So my next step is to use a mole ratio. The mole ratio, I get it from my balanced chemical equation. I have 3 moles of carbon for every 1 mole of SiC. 1 mole. Remember that if there's no coefficient, that means that there's a 1. Okay? The reason that I wrote moles of carbon in the bottom is, remember, so the units cancel each other out. Now I am in moles of SiC. So I've made that jump from one compound to the next, but now the question is asking me for grams, not for moles. So I need to do one more step. And in this step, I'm going to have to go from moles to grams. Remember, the way that I know how to do that is by using the molar mass. So I have to find the molar mass of SiC. So I need to go to the periodic table. I have 1 and 1 of each. So I need to go to the periodic table. Silicon is 28.09. 28.09 grams per mole. And carbon has a mass of 12.01 grams per mole. I add both of these to find a total mass of 40.10 grams per mole. So I'm going to get this number and I'm going to put it somewhere in the next step. Now, since I have moles in the top, down here, I want 1 mole of SiC, and in the top, I'm going to write the mass, 40.10 grams. Then I'm going to take my time and actually cancel out the units that cancel out. The only unit that's not crossed is grams of CiC, and that's what they're asking me to find. Okay, so I'm going to get my calculator, get 2 divided by 3, multiplied by 40, and that gives me 26.7 grams of SiC, and that is my final answer. So question 5 says, sodium peroxide reacts vigorously with water in the following unbalanced chemical equation. Unbalanced. So before we even read the second part, we're going to go ahead and balance this equation that we know that it's unbalanced. So again, I'm going to write all my compounds in the bottom. All my elements. Count. I have 2 sodiums, 2 oxygens here, plus another one here. That's 3 oxygens. And 2 hydrogens. On the product side, I have 1 sodium, 2 oxygens, plus 1, 3 oxygens, and only 1 hydrogen. So my sodiums and my hydrogens are not balanced. So to balance that, I'm going to put a 2 here. This 2 affects sodium. Now I have 2. Oxygen, I have 2 here, plus another 2 here. That's 4. And hydrogen, I have 2. My sodiums are balanced, my oxygens are not, and neither are my hydrogens are. So to fix the oxygens, I'm going to put a 2 here. But by putting a 2 here, now you have 2 oxygens plus 2. That's 4. And hydrogen, now I have 2 times 2, 4. So that means that now I need to fix this coefficient here because I need to have 4 hydrogens, so I need to put a 4 here. Now I have 4 sodiums, 4 oxygens plus 2, that's 6, and 4 hydrogens. My hydrogens are balanced, my oxygens nor my sodiums are. So I need to add a coefficient here of 2. So when I multiply 2 times 2, I have 4. 2 times 2, I have 4 oxygens plus 2 on this side, that is 6. Okay, I have the same amount of sodiums, same amount of oxygens, same amount of hydrogens. I finally balance this chemical equation. Now I'm going to go ahead and read the second part. What mass of oxygen, so they're asking me for mass, remember mass is grams, question mark, of oxygen is produced when 50 grams of sodium oxide reacts with water. So they're giving me 50 grams of Na2O2. Okay, this question, they're giving me the information in grams, and they're asking me to find the grams of another compound. Okay, so I'm going to start by writing what was given to me. 50 grams of sodium oxide. Okay, now remember that I always need to use a mole ratio in order to jump from one compound to the next. But in order to use a mole ratio, I need to be in moles. And right now I am not in moles, I am in grams. So the first thing I need to do is turn that grams into moles by using the molar mass. So I need to find the molar mass of Na2O2. Okay, so I'm going to go to the periodic table. I'm going to look for sodium. Sodium has a mass of 22.99. 22.99. There's 2 of them, so times 2. That gives me 45.98 grams per mole. Oxygen has a mass of 16. There's 2 of them. I multiply and it gives me 32.00 grams per mole. To find the mass, I add both of these numbers. It gives me 77.98 grams per mole. Okay, so now this number, I'm going to put it in the bottom, okay, because I want grams and grams to cancel. Grams of Na2O2 for every 1 mole of Na2O2. Remember, the reason that I want this is for grams and grams to cancel each other out. Now that I'm in moles, now is when I'm going to use the mole ratio to go from moles of one compound to moles of another. Okay, so I'm going to use 2 moles of Na2O2. Remember, I wrote it in the bottom, so the moles and moles of the same compound cancel out. For every, if there's no number, that means there's a 1 mole of oxygen. I'm going to go ahead and cross moles of Na2O2 and moles of Na2O2. Now, the only unit that's not crossed over is moles of oxygen, but they're not asking me for moles, they're asking me for grams. So I need one more step in where I go from moles of oxygen to grams of oxygen, and I do that by using the molar mass of O2. Okay, not just of oxygen, but of O2. So there's 2. Each oxygen has a mass of 16. That is 32.00 grams per mole. Okay, now in that case, I'm going to write this number in the top. 32.00 grams of oxygen for every 1 mole of oxygen. Okay, I write it in the bottom, the moles, so the moles and moles cancel out. So now I'm going to get my calculator. Okay, I left my calculator in the class, so I'm going to use my phone. And I'm going to do 50. If the number's on top, you multiply. If the number's in the bottom, you divide. So 50 divided by 77.98 divided by 2 times 32. And the answer, I don't have space, I'm going to write it here. The answer is 10.25. Now, since my original number had 3 significant figures, I'm going to round this to only have 3 significant figures. So the 10 stays. I'm going to round to the 3. Since we have a 5, it becomes a 3 grams of oxygen, and that is my final answer. And the last question, question 6. It says, if 0.5 moles of NaN3 react, what mass in grams of nitrogen will result? Okay, so they're giving us 0.5 moles of NaN3. So 0.5 moles. And they're asking us to find what mass in grams of nitrogen. Nitrogen, question mark, grams. Okay, so this question is giving us the information in moles. And they're asking us to find grams. There's going to be a mole to gram type of question. Remember, the first thing I'm going to do is I'm going to start with the number that was given to us. Moles of NaN3. Okay. Remember that I always need to use a mole ratio in order to jump from one compound to the next. But I need to be in moles, which I am in right now. So my first step is going to be to use the mole ratio. Okay, the mole ratio comes from my balanced chemical equation. So I have 2 moles of NaN3 for every 3 mole of N2. The reason that I do this is the moles of NaN3 cancel out. I'm left in moles of nitrogen. the question is not asking me for moles, it's asking me for grams. So I need to do one more step. And in that step, I need to turn moles of nitrogen into grams of nitrogen. And I do that by using the molar mass. Okay, so I need to find the molar mass of N2, which I have 2 nitrogen. Each one has a mass of 14.01, 28.02 grams per mole. Okay, since I have moles here in the top, I want moles of nitrogen in the bottom. So in the top, it's going to be 28.02 grams of nitrogen. Here, the moles cancel out, and the only unit that's left uncrossed is grams of nitrogen, which that is what my question is asking me. So my final step is to get my calculator. If the number's in the top, I multiply. If it's in the bottom, I divide. So I'm going to get 0.5 divided, 0.5 times 3 divided by 2 times 28.02. And it gives me 21.01, sorry. 21.02, or just 0.0 because 3 significant figures. So 1, 2, 3 grams of N2. Okay, and that is my final answer.